Recap what we did Friday. So Friday, if you recall, we did a little activity to kind of introduce this idea, of like where these relationships are going to go and how we're going to use them. And so on Friday, you had your 3 different objects, so you need to pretend they were 3 different elements, and you had 12 of them, so you had a dozen of each of them. And so the first relationship with the word dozen is one you've known your entire life, is the idea that a dozen means 12. Right? You walk into the donut shop, you don't order 36 donuts, you order 3 dozen, but we all know that means 36 donuts, right? So chemists have a word that means a number also. So when we talk about how many atoms are in a sample, instead of saying there are 4.2 times 10 to the 24th atoms in the sample, we talk about how many moles are there, all right? So your first key relationship to get down is, what does the word mole mean? Right? Again, you all know dozen means 12, a pair means 2. I think the video, like a gross means 144. There are words in your life that mean number. So for a chemist, the word mole just means a very specific number. So that's the first relationship we're going to get down. It's our first goal today. Okay? So the mole. When you abbreviate the mole, you just drop the E. You can't just put an M because that's meters. And you can't, I don't know why they didn't do MO, but they didn't. They do MOL. So when we use it inside of our math, your abbreviation, your unit for it is MOL. And this first bullet point is the technical definition, or the original definition of the mole. Right? I'm not going to stress that you memorize this. We're going to use it a lot, the number, but at some point in history, somebody had to have decided that the word dozen meant 12, right? I assume it's how things fit in an oven. So this is where a chemist has decided where this number comes from. So the technical definition is it's the amount of a substance that contains as many particles as there are atoms in exactly 12 grams of carbon-12. So if you were holding exactly 12 grams of the isotope carbon-12, and you were to physically count how many atoms were there, that's where this number comes from. Okay? And you can look up online, you can look up much more numbers than we're going to use. We're going to kind of shortcut it down to 4 significant figures. So it's kind of like in math class, like pi is like 3.14159, blah, 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 but you always just do 3.14, right? So the number is 6022, blah, 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 but we're going to shortcut it down to just 4. Okay. So that's where the number comes from. The relationship you need to know, this is from the video we watched on Friday, is that 1 mole of something is equal to Avogadro's number. They named it in honor of him. If you remember from the video, he's the one that theorized this idea. That's him. He never calculated the number. He just theorized about it, but they named the number in honor of him. Because honestly, saying Avogadro's number is sometimes easier than actually saying the number, because the number's kind of annoying. Right? And that number is 6.022 times 10 to the 23rd. And if we wrote that out in normal notation, it would be 6022 and then 20 zeros. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? So obviously, again, on the video on Friday, you saw it written out in standard notation, right? But that's what the number is. So again, the word dozen means 12. A mole means this giant number, right? And then again, in the video, we likened it to the idea, if you had a mole of donuts, it would cover the earth 5 miles deep. If you had a mole of basketballs, you could make a planet the size of Earth. If you had a mole of pennies, you could spend $1 million every second for your entire 100-year life, and you would still have most of your money. It is a gigantic, gigantic number. But because atoms are so small, they're tiny, you can hold a mole of atoms in your hand. All right? So if you hold about 12 grams of pencil lead, so if you have a mechanical pencil, it's probably 12 pieces of pencil lead thereabouts. That's a mole of atoms, of carbon atoms. Okay? But that's what the number means. So your first relationship that you have to get down is this. 1 mole is 6.022 times 10 to the 23rd atoms, right? Because we're going to count atoms.
What are the A? What's the A?
I'm going to get you. The A is any element. So 1 mole of carbon is 6.022 times 10 to the 23rd atoms of carbon. 1 mole of magnesium is 6.022 times 10 to the 23rd atoms of magnesium. Just like on Friday, a dozen paper clips meant you had 12 paper clips. A dozen markers meant you had 12 markers. A mole here means you have 6.022 times 10 to the 23rd atoms. Okay? This is your first relationship you have to get down. That a mole is our way of kind of bundling atoms together so that we can talk about it much easier. Right? Nobody wants to constantly say, I've got 2.25 times 10 to the 25th atoms of something. All right? Chemists just know how many atoms are there based on how many moles are there. Again, just like you know that 3 dozen donuts means 36 donuts. Right? So it's the same kind of idea. So we'll practice these relationships first, because the calculator part is part of our deal today. You got to learn how to type it in. All right. So it says, how many moles of carbon are in 2.25 times 10 to the 22nd atoms of carbon? Okay, so just like last unit, when we did our dimensional analysis, when I read the problem, it says, how many moles? I'm going to box that, because that's what I'm looking for. At the end of this, I want to know how many moles. Kind of like how many dozen would be the question you could ask about your cupcakes. Are in 2.25 times 10 to the 22nd atoms of carbon. There's your starting number. So just like last unit, you're going to have a measurement to start with. And all you're doing is changing one measurement unit to another. Just like last unit, we changed inches to feet, or we changed inches to centimeters. We're just going to change atoms to moles. Write the number down, just like we did last unit, and your atoms will always be really, really large numbers. I put a 25. 22nd. Now, atoms is our unit. There is no official abbreviation for atoms in science. In theory, or technically, we should write the word out, but we're not going to do that because I don't feel like writing it all the time. So we're going to do AT for atoms. That'll be our abbreviation in here. And then I want you to get in the habit of including the element symbol. We're going to go places with moles. By the end of the year, we'll make like probably at least 10 different relationships with moles. So we will eventually go from like moles of carbon to moles of carbon dioxide. So I'm just trying to get you the habit now. So just include the element symbol at the end of your number and unit. So it should be number, unit, element symbol. And then think back last unit. We always multiply by a conversion factor. If atoms is on the top, where does it have to go? On the bottom. So atoms of carbon has to go on the bottom. And just like last unit, you're going to ask yourself, well, what do I know that atoms relate to? Right? Last unit, it would be like, what do inches relate to? And there's like 1,000 things you can come up with. Right now, you only know one thing. You have only one option. Atoms relate to moles. That is your only possibility. So atoms have to relate to moles. So atoms to moles is your conversion. Then you're going to ask yourself, well, how are they related? Well, we just wrote it down. 1 mole is 6.022 times 10 to the 23rd atoms. And that's always true. Doesn't matter what element you're talking about. 1 mole, if you are counting how many atoms are there, is always 6.022 times 10 to the 23rd. Right? And then atoms cancel. And we're going to just do kind of short problems today. We'll do our math. Think back last unit. On the bottom, what do? Divide. This is where I want you to practice in your calculator. Okay? I know most of you have probably done like the times 10 to the key, right? When you've done scientific notation. I don't want you to use that. Okay, so all of you get out your calculator. And this is how you're going to type in scientific notation in here. Okay. We're going to look at the first number. You're going to type in 2.25. Like that's not going to change. 2.25, type it in. Okay. And then instead of the times and the 10, we are going to replace that with a capital E. You will find the capital E behind your comma. So find the comma key, and above it you should see EE, like 2 capital E's. All right, so you just want 1, so you're going to hit second comma. And it should put the capital E there. So that takes the place of the times and the 10. But what it also does is it makes sure order of operations doesn't mess you up. Okay? And then you're just going to type the 22 for the exponent.
Thanks.
22, right? And then it's division, so divide. And then the other one, again, you're going to go 6.022. And then do not type times, do not type 10. Second comma and put the E there. And then 23 for the exponent. Okay. So again, it makes it so parentheses are not required. It makes it so order of operations gets done correctly. If you type it the right way, all of you should get, I don't remember the answer, what's the most spell?
I got quit.
I got a 0.
Okay, well, some of us are going to have to go back and listen to how we type it in. You should get 0.037363 blah blah blah. All right. So if we didn't get that, at some point I will gather you today to make sure. Your starting number has 3 significant figures. Avogadro's number, the way I make you learn it, has 4, so we'll keep 3. So we would correctly record this as 0.0374 moles of carbon. If you're not getting the number, I will come find you and we will fix your calculator. Because that's part of the day is learning to use your calculator correctly. Now, this seems strange. You're like, I have a decimal number. Okay, this would be kind of like, you could walk in the donut shop and say like, or you could say like 4 donuts is 0.33 dozen. It'd be weird, but you could do it, all right? You can do decimals with a mole, all right? Because it's so large that you can have fractions of a mole very, very easily. Okay. If you ever type in your calculator and you look and you have like the E at the end and it has like 40 something, you did it wrong. All right. E with a 41 or 2 or 3 or whatever is more than there are atoms on Earth, more than there are moles on Earth, more than the mass of the Earth. Okay. So E, like E40 whatever at the end means you typed it in wrong. Okay. We'll do one more and then we'll do the other relationship and then I will help you with calculator things. All right, you can also go the other direction. So this would be like, how many donuts are there if I have 4.5 dozen? How many atoms? So there's our question. We want atoms. And again, AT is our abbreviation because we're going to make up one up. Of sodium are in 3.80 moles of sodium. So again, like last unit, copy down the number with the unit, so moles, and then include the element symbol. So that sodium is Na. Unit on the top automatically has to go where? On the bottom. So moles of Na have to go on the bottom. And so for moles, now moles will eventually be related to a lot of things, right? But right now you only know one. Right? So moles relate to atoms. So we can turn moles into atoms. And then what is the relationship? 1 mole is 6.022 times 10 to the 23rd atoms. And honestly, for the next month or so, probably almost month and a half, when you're doing your conversion, moles is going to get a 1. Okay, like it'll never have anything but a 1 for a little while. What are you going to do with your 2 numbers this time? Times. So your calculator, you should type 3 if you like to put the O, you can, you don't have to. Times, and then you're going to type 6.022, and again, no times, no 10, second comma, 23. So you should type in 3.8 or 3.80 times 6.022, second comma, 23. Got to include the exponent. And so you should get 2.288 blah, blah, blah. And you need to get in the habit of looking at the end of your number. You should have an E there at the end. Every time you solve for atoms, you better have times 10 to the 20 something. All right, there's always a lot of atoms there. We'll keep 3 because this has 3 significant figures. This has 4. We'll keep 3. So we'll keep 2.29. And then again, atoms are always going to have times 10 to the something. So times 10 to the 24th atoms of Na. And again, the E just means times 10. Always with atoms. Right? You should always have a times 10 to them. So the first part of your worksheet, or your see what you said today, is going to practice this relationship. Okay? Moles is how we count how many atoms are there. Okay? Just like a dozen is how a baker counts how many baked goods are there. Okay? But where we're a little different than a baker, right, is we can't physically count out our atoms, right? They can count out your donuts for you. As they make your box, they count to 12, right? We can't do that. There's no, oh, there are instruments, but it would not be feasible money-wise. There's no easy instrument that's going to count atoms for us in a sample. There's also no easy instrument that measures moles. In a lab, we can measure mass and we can measure volume. Those are the two easy things for us to measure. So we need to be able to relate this idea of a mole to something we can measure. Okay? And that's your second relationship. So we need to relate it to what we can measure it. You don't need to write that down. And the thing we're going to do is we're going to use what's called molar mass. This top bullet point is your definition. Okay? So here's your analogy from Friday. On Friday, we found dozen mass, right? You put all 12 of your paper clips and found the mass of a dozen. You put all 12 of your keys and found the mass of a dozen. So a chemist takes whole mole of an element and puts it on the balance to know what its mass is. Okay? We call it molar mass because it's the mass of 1 mole. Okay? It does have to be for a pure substance. So in case you forgot, pure substances are elements or compounds. So for now, we're just sticking with elements because we haven't learned about compounds. So it's the mass of 1 mole of an element. So if you could take a whole mole of carbon and put it on the balance, what would its mass be? If you can take a whole mole of sulfur and put it on the balance, what would its mass be? Okay. The units are grams per mole. And the very bottom is a really, really important relationship. It is numerically equal, so same number, to the average atomic mass of the element. So in case we forgot from last week, that is your decimal number on the periodic table. Okay, so that number has 2 meanings to a chemist. All right? It is the average mass of 1 atom in atomic mass units. Okay? It's also the mass of a whole mole of those atoms, so 6.022 times 10 to the 23rd of them, in grams. Okay? So every element gets its own number. And that should make sense. On Friday, a dozen paper clips had a different mass than a dozen keys, right? A mole of carbon is going to have a different mass than a mole of sulfur, right? You said on Friday when you were talking with your friends that it made sense because they're different material, they're different sizes. So are your atoms, right? They have different protons, they have different neutrons, okay? So they're going to have different masses. So for example, calcium, if you had an entire mole of calcium in your hands, okay, if you could hold it, you shouldn't hold it because it would react with your hands, but that's fine. If you were to hold it, it would have a mass.
Wait, this is a relationship to
Yeah, this is your relationships. It has a whole mass of 40.08 grams. Okay, so if you were holding 6.022 times 10 to the 23rd atoms of calcium, a mole of calcium, it would have a mass of 40.08 grams. If you were holding half a mole, it'd have a mass of 20.04 grams. Okay? Just like on Friday, again, you did everything in groupings of a dozen. Chemists do everything in grouping of a mole. If we did this for zinc, all right, different atoms, different protons in there, a mole of zinc is going to have a mass of 65.39 grams. All right, so that number on the periodic table will tell you what the mass of 1 full mole of that element is in grams. So again, Friday, you found the mass for dozens of things. Chemists find it for moles. So your second kind of key relationship is 1 mole of any element, that's your A, is the periodic table number of grams. You can't like write an actual number down because it's different for every element. But you have to look on the periodic table to find the grams. So that's your second relationship. Okay, tomorrow we're gonna pop them together, but it should go quick if you get the 2 relationships down. So we learned moles and atoms. Moles lets us count how many are there. We also are gonna relate moles to what mass they would be. So we'll do our 2 examples, and then you're gonna talk to your friends and work together. So it says, what is the mass in grams? So there's your question. We are looking for grams of 3.6 moles of the element carbon. Okay, so same problem solving as last unit. Copy down the number and the unit, so 3.6 moles, add in the symbol on the end. That's the top of your fraction. You're going to multiply by a conversion factor. What absolutely has to go on the bottom? Moles. All right. Here's where you're going to have a little bit of an issue, right? Moles has 2 relationships you now know, okay? You gotta stop and ask yourself, what do I want to relate it to? Moles relate to atoms, and moles relate to grams. Just like last unit, inches related to feet sometimes, but then sometimes inches related to centimeters, right? Depending on where you were going. So in this case, because we want grams, we're gonna take our moles and we're gonna turn them into grams. So we're gonna turn them into grams of carbon. Again, the point of today is to get comfortable with where do I find the numbers. So for grams, all we ever do is look on the periodic table. Find carbon. It has a mass of 12.01 grams. And then moles, and I told you this, in your conversions, moles gets a 1 for a long time. Okay, it's like inside of your little fractions, moles has a 1 for a long, long time in here. And we do our math. This has, no, definitely not 4 significant figures. So this one has 2. This one has 4, so we'll keep 2, and it should be 43 grams. So you don't buy your baked good by the mass, but you do buy your salami this way, right? So like you would buy how many grams of salami you want, and then they know how many slices, or you probably know how many slices that would tend to be. And that's our goal tomorrow, is to take grams all the way to atoms. The other direction, I just want to make sure they're in your notes so you can see the different directions things can go. This one says, how many moles? So again, problem solving strategy, box what you're looking for. Generically, it's moles, grams, or atoms for this unit. So how many moles of copper are in 3.22 grams? Underline your starting number. Just trying to help you like strategize how to do these problems. Write it down. 3.22 grams. What's copper symbol? Cu. Nice. All right, that starts the top of your fraction. Right. What has to go on the bottom? Grams. All right, and grams does relate to a lot of things, right? Like the last 2 questions for today on your CYU said you're going to go back to the density we did last unit. But the biggest thing in chemistry that you need to get down is that grams relate to our counting unit. All right, the mass that we measure in the lab relates to how many atoms are there. So grams to moles will be probably the biggest relationship we do all year. Where do you look for the grams? Where did I tell you? Periodic table, atomic mass. Find on the periodic table. Copper is number 29. So its decimal is 63.55 on your blue periodic tables, and then 1 mole. It's on the bottom, so what do? Divide. We started with 3 significant figures. Most of your masses on the periodic table have 4 or 5, so we'll divide 3.22 divided by 63.55. It's a small mass, so 0.050, or small number of moles. It's not very much. And what we're going to practice today is these 2 relationships. Right? So the first 4 are going to be the atom relationship, and then the next 6 are going to be the gram relationship. Tomorrow we'll put them together, and then you'll do like a mixed review, or like it could be any direction to get the relationships down. And that is the rest of your day in here. Through number 10 on your CYU set.